Hi everyone, my name is Abhilash and I'm the instructor for this lecture, and today we're going to be discussing limits and we will solve 10 problems on this topic by using a simple strategy, and we will use this strategy to solve such problems. Let's take the first problem. In this problem, firstly we need to put the limit first, and if you put the limit, the numerator will become 0 and the denominator will become 0 again. And in such case, if you see the numerator, you can factorize this numerator. So you can write like this. Now if you notice, x minus 2 will be cancelled from numerator and denominator. Now let's do the start point. Put the limit first. Now if you put the limit becomes finite, which is 2 minus 1 gives you 1. You could have done this problem with a 6th point, which is the L'Hopital rule. Now in this method, we need to differentiate the numerator as well as the denominator. Now you can see that we have differentiated both the numerator and denominator. Now you can do the start point. Put the limit first. Now if you put the limit, it will become 1. We'll get the same result by doing these both methods. Let's take another problem. Here limit is tending to infinity. It means the x is tending to infinity, and we are given two polynomials in numerator and denominator. In such cases, you need to take the common x from both the numerator and denominator, because the highest power is same in both the cases. So you may write like this. Now if you notice, x cube gets cancelled from numerator and denominator. Now let's do the start point. Put the limit first. Now if you put the limit in here, it will become 0 because 1 by x, and if you put limit x equals to infinity, it will become 0. It means all these 6 terms will get 0 and we're left with 1. You could have done this problem with number 6th point, which is the L'Hopital rule. I will leave it for you. And this problem was based on infinity by infinity form. So in such cases, you may use the third point, which is take x common for limit x equals infinity, or you may use L'Hopital rule. This L'Hopital rule is a universal rule. You may apply to any of the limits. Let's take another problem. Here, limit x tending to infinity. If you put infinity in this place of x, you will get like this, infinity minus infinity form. In such cases, you may use the second point, which is rationalization. If you rationalize this term, what do you get? For rationalization, you take this term here and put the inverted sign, which is the plus sign for both the numerator and denominator. It means that we are using this term and multiplying it and also dividing it. So the resultant is same. Now you need to take these two terms, these two and this one, and multiply them. And you may use the square to remove this square root. Now on solving this expression, you will get. Now let's do the start point. Put the limit first. Now if you put the limit infinity in this place, the whole term will become 0, and it is a finite number. So you may write the result as 0. Okay, for the whole limit. Let's take another problem, and don't worry about this problem number, because I have taken all these sample questions according to the difficulty. Okay, let's start with this problem. We have this limit x tends to 0, and we have sine 3x divided by 6x, and in this case we have sine x, and if you see sine x in the numerator or denominator, try to see the argument, and the argument is 3x. Now what you will do is take this argument, okay, and divide this argument and multiply it accordingly. Thus the resultant is same. Now what you will do is take this 3 sine x and place in the denominator of sine 3x like this. And if you see here, limit x tends to 0, sine 3x divided by 3x will become 1. It is due to the fact that if you see the expansion of sine 3x and divide this sine 3x with the 3x, you will get the result as, and now if you place limit x equals to 0 in front of it, so you will get 1 as a result, because this 0 will be placed in this term, and all the terms will be cancelled except this 1. So 1 is the answer for this one. And note that we have limit x equals 0 on both the sides. So you can replace this term with 1 in this equation. Now you're left with the 3x divided by 6x. You can cancel the x. The answer to this problem is 1 by 2. Let's take another problem. In this problem, we have 10x as the argument. You need to do this. Now, in the previous question, we have done the same thing. So in this case, it is similar. So this term will get to 0 when the limit x tends to 0. Now, in this case, 10x divided by x when limit x tends to 0 is a similar case of sine x divided by x when limit tends to 0. So it is similar to that problem, and also you may check with the series of 10x divided by x and put the limit x tends to 0, and you can get the same result. Let's take another problem. We have limit x tends to 0, x square into log x. Now if you put the limit, you get x0 into log 0 is infinity. It means that it is 0 into infinity form. In such cases, I'm converting it into infinity by infinity form. How can I make it? I have modified this form like this, and now if you check this form, it is infinity divided by infinity form. Now in such cases, you can use the 6th point, which is L'Hopital rule. Differentiate the numerator as well as the denominator and place there as it is. Now you may write this term as like this. Now if you put the limit first, so you will get 0. Okay. Now if you see this problem, we also have this 0 into infinity form. Okay, it is similar to the previous one. You need to convert or modify this expression like this. Now use the L'Hopital rule to differentiate the numerator as well as the denominator. After the L'Hopital rule, it will look like this, and you can rewrite the expression like this. And if you notice here, this form is 0 by 0 form, because if you put the limit of x tends to 1 in this place, it will be 0 by 0 form, and you need to differentiate again both the numerator and denominator. You will get like this. And if you see this, you can cancel out pi over 2 and pi over 2 in this numerator and denominator. Also, you may cancel out 2 from numerator and denominator. Now if you put limit x tends to 1 in this both the numerator and denominator, it is again 0 by 0 form, and you need to differentiate again with the L'Hopital rule. Now on differentiating both the numerator and denominator, you will get this, and you can put the limit now, and in total the resultant will be minus 2 over pi. Also, you could have solved this problem in this manner. When it was the form of 0 into infinity, you could have modify like this so that it can be done to 0 by 0, and you can differentiate it with the numerator and denominator by the 6th point L'Hopital rule, and the numerator will be 1 and denominator will be minus cos x square pi x by 2 and pi over 2. And if you place the limit x equals to 1 in this place, so the answer is same. You need to choose which path is more easier to solve in the exams. Let's take another problem. Limit x tends to 0, 1 by x minus 1 by 10x. In this problem, if you put the value of x here, it will be infinity minus infinity. So it is a problem of infinity minus infinity. In this case, you need to cross multiply the terms which are in denominator. So it will look like this. Now if you notice here, if you put the value of x as 0, it will be 0 by 0. So we converted the infinity minus infinity form into 0 by 0 form. Now what can you do is, you can use the L'Hopital rule to further find the derivative of the numerator and denominator. After saying it is a 0 by 0 form, you can use the 6th rule, which is L'Hopital rule, or you may use the fact that you can multiply the tan x by x and also divide it by x so that the resultant remains the same, and you can use the limit x equals to 0 on this tan x by x, which becomes 1, and also in this case of the denominator it will be 1, and on doing so you will left with 0 because x and x will get cancelled out. Let's take another problem, and in such problems if you see e to the power of anything, make sure that substitute u equals to e to the power 10 like this. Now take the log on the both sides, and now putting the limit x tends to pi by 2 plus on the both sides. Now if you see the graph for 10x along with the x equals to pi by 2, and it is a graph for 10x, and if you see the pi over 2 in this place, so you can see that there is asymptote on the positive side of y-axis and also negative side of y-axis. See there, the limit x tending to pi over 2, that is the pi over 2, and here the plus means that we need to see the value at the right side of the pi over 2. If it would have been minus sign, we would like to see the left side of the pi over 2. But in this case we will see the right side. If you see the right side of the pi over 2, it is the negative side of the tan x. Let me zoom it. And if you see the pi over 2 in the right side, and the right side of the pi over 2 is something going at the negative y direction, and will meet at some point. So there may be some value and we need to find it out. The tan x at pi over 2 is minus infinity, and if we also talk about the right side of the pi over 2, it will be minus negative infinity. So we will write minus negative infinity in place of the limit x tends to pi over 2 plus tan x. So lastly, so limit x tending to pi over 2 plus of u is equal to 0, and you can write this as 0. Okay, let's see another problem, and the last one. Here if we talk about this problem, and we will let u equals to x power x, and if you see, take the log both sides, and the log should be of base x because it is of the x, and in previous case it was of e power 10x, so we used the log base e. So now we can write like this, and you can write limit x of x tends to 0 as 0, and you can replace the same as it is. Okay, and also you have to find out the limit of x tends to 0 of u, so you can take this log x to the other side, and you will see like this, 0 equals to 1. And let's take the second problem. We will let u equals to x to the power sine x as we had done in the earlier case, and we will take the log on the both sides and with the base of x, and also we will put the limit x equals to 0 on the both sides. Okay, and also if you see the right side, we will multiply x and also divide by x, so the resultant will be same. And if you notice that limit x tends to 0, sine x divided by x is converging to 1, and we will left with the x, and you can write limit x tends to 0 x, put limit x tends to 0 in this place, it will be 0, and it is already equal to the limit x tends to 0 log u base x, and you can find the value of the limit x tends to 0 u equals to, you can take this log to the other side, and this x to the power 0 would be equal to 1. So the resultant answer or the final answer would be 1. And I hope you enjoy the tutorial for these limits. Don't forget to subscribe my channel. Stay at home and enjoy the corona vacation.